the minimum. When I switch on the minimum electrostatic field, what are the various forces? Electrostatic force Q into E minimum, then normal contact, then friction, then component of weight. Okay, these are the various forces that are acting. mg sine theta, mg cos theta, friction, and there's a normal contact. This angle will be as usual theta. Okay, I'll do one thing, I'll make it alpha. Because Q and theta you may get confused. So the angle of inclination, let me make alpha, where tan alpha is greater than mu. No, what conditions will arise? For first perpendicular to incline, first case we are discussing, no? So perpendicular to incline. Perpendicular in time, what are the forces? N minus mg cos theta minus q e minimum, sorry, cos alpha. I have to change the angle of inclination to alpha. So q e minimum sine alpha equal to 0. Then parallel to incline. Parallel to incline, mg sine alpha minus f q e minimum cos alpha equal to 0. What is further? F should be mu n. Substitute n value from here. What is n? N equal to mg cos alpha plus q e minimum sine alpha. E minimum, so this will be equal to mg. One mu is there, no? Yeah. Cos alpha plus mu sine alpha. So this will become mg by q tan alpha minus mu 1 plus mu tan alpha. So the electrostatic field is greater than E minimum. The point charge will not slide. Carefully look at the conditions now. I'm going to change. Okay, there's a for initial part of the first one, E minimum. I'll keep on increase the electrostatic field. Then the electrostatic force acting on point charge will increase. Then component of this force along the incline will increase. Then at one instant, when this Q E minimum cos alpha is greater than mg sine alpha, the friction will change direction. The friction will act down the incline. The block is about to slide up. Then that particular E minimum, what happened, will become E max here. The same diagram. Let me take the same diagram. This will be now when it is E max. We are discussing the second situation, Emax. For Emax, the friction will act down the incline. All the conditions. So this will be Emax, you write it. Well, why you should change this one? Because the component of field, as they keep on increasing the electrostatic field, then a component of electrostatic force along the incline will be such that it is able to overcome these two forces. So the block is about to slide up. There's a maximum electric field for which the point charge can be in equilibrium. Again, perpendicular to incline, the forces acting will be N is equal to mg cos alpha plus E max sin alpha. Then this is along the incline. Perpendicular to incline. Okay, sorry, this is the perpendicular to incline. Now along the incline. Along the incline, mg sin alpha plus f minus q E max cos alpha equal to 0. So if you solve for E max, so I'll end up with mg by q tan theta plus mu 1 minus mu tan alpha. So what is the condition? If E less than E minimum, for equilibrium. Why I'm writing this? If E is less than E max, yes, it can be in equilibrium. If the horizontal electrostatic field is less than E max, the charge particle will be in equilibrium. Then what is the condition? Here E should be greater than E minimum. So therefore, what is the range for the electrostatic field for an equilibrium? As long as the applied horizontal electrostatic field, if it is lying within this, the particle will be equilibrium on an inclined plane. It should be greater than E minimum, E max. So there's a range is telling. So as long as the applied electric field lies within this range between E max, E minimum, the point charge will be in equilibrium. There is a one value of electrostatic field at which friction will be 0 also. Please do think. I want students to think. There is a one value of electrostatic field at which friction acting will be 0. In that case, what should be the value? Q E naught should be equal to mg sin alpha. I don't have place here to scribble. I'm just putting the idea, sharing the idea. There is a one specific value of electrostatic field called as E naught, at which the friction acting between the point charge and the rough inclined plane will be 0. What is that? Q E naught should be equal to mg sin alpha. So what is that value? So let me write it here. E naught should be equal to mg sin alpha by q, where friction will be 0. No friction force will act. There's also one condition.